Hey, Terry.
Hi.
Hey, good.
Irene.
Thank you for being sorry, I was here for the last 20 minutes and then a couple people tried to join and they wouldn't put their audio on. So I
Yeah.
didn't know if the audio
Yeah.
up or what. Anyway,
There is a reverb in there. I
is
don't know
there?
where. Yeah. Let me check my microphone is good. Speakers are good. I'm good here. Are you hearing the might have been Christoph, maybe it's yours.
Maybe is there a reverb on there now?
No.
Hmm. Okay. All right. Well,
How are you? Where are you?
where am I?
Yeah.
I'm still in Paris. I'm still in
Oh, horrible place.
It's kind of rainy and dreary right now. How's beautiful Northern California?
San Francisco is identical right now to that. It's a little dreary, a little wet for sure. It's been raining for days now. No
Okay.
complaints. We need every drop, so no complaints at all.
Yeah, that's true. California does need every drop. Um, so hopefully Dr. Burns was here and then he didn't seem to be able to get his audio and video to work. So he emailed me. So I emailed him back asking him to rejoin. So hopefully he will. In the meantime, I'm gonna put the two of you who are here already. We're a couple minutes ahead of schedule. I really appreciate you being here. I'm gonna put you in the waiting room just for a minute while I put Terry and hopefully the other speaker into our little Zoom room. Okay, so just gonna put you in the waiting room just for a minute, and then we'll pull you right back. Christoph, I wish you would unmute. It would be nice to say hello. I'm going to put you in the waiting room again for just a second.
You got him
Okay,
for a second.
so Terry, if Dr. Burns does a no-show, are we going to be okay or?
I can riff on anything. Literally, I can riff on all things science. I have to say, doing this, working on this project past couple of weeks now, a little more concerned than normal. Oh, cool. That's really
There we
neat.
go. I don't
That's
know
neat.
why you're smaller than me. I don't understand why.
I can get closer. Hi. That's really neat.
Is it fun? Is it comfortable? If it's not comfortable, we can go back
No, no,
to.
no, it's good. I will keep my video on. I'd rather look at the person I'm visiting with, but in this case, this is really neat. So who cares? Now it'd be really cool if you had Mars in the background
Oh yeah, that's true.
right
That's
there.
true. That is true. Yeah.
Paris, God, I can't wait to get back.
That's
Honestly,
well that yeah, you guys seem to have had a really fun time when you were here.
yeah.
Yeah.
But I'm not a partier, but I just love the environment. I love the place, right? So, and the people. That was fun.
Well,
Anyway,
there were so many of you here all at the same time. Yeah, I couldn't believe the turnout to that. That was so great.
I gotta say, she's cracked the whip good, right? We were all kind of following her lead, and it was kind of funny too. She wasn't gonna come, and I was like, "Hey, you're gonna come to Paris, right?" And she goes, "Well, no, I wasn't going to." And I'm just, "That's silly. You have to be there." She decided like the night before. She caught a flight. We had a place for her to stay. It was done. It was really neat.
Oh
Cool.
wow. Well, yeah, she
Of
really is
course.
the ringleader, isn't she?
Oh my gosh, she is the ringleader.
Yeah.
Absolutely. Definitely. Anyway, so and then of course Jess, all of those folks that are all around, in Europe. I like Europe a lot. You know, I'm an Irish citizen. I don't know if you knew that.
No, I didn't know that. Somehow that doesn't surprise me though, with your sort of happy-go-lucky way about you.
Yeah, citizen, an actual citizen of the Republic, of course, not the North.
Well, that's cool. That actually means then that you are an EU citizen. That means you could stay as long as you wanted.
Yeah, and I don't know. I may try to domicile part of our business there in Dublin. We'll see. I'm thinking it through. I
Cool.
think, yeah, I think it would be. I don't know. I think it would be a good idea, in my opinion. Um, I don't know. We'll see. It's so funny, you know, the ESA dollars, ESA euro are fairly significant. So we're just hoping to get a small piece of that. And Ireland, I think Ireland pulled out 2 million euro out of a recent project, and that's it. And they have, I don't know, some crazy number like 200 million available to them. And I'm like, well, I can think of lots of things that we could do with that.
Oh, wow, that's interesting. That's interesting. So all space allocation.
Yeah, yeah, and you know, France has no problem pulling because Airbus is there, and you know some of the other biggies, Sines, you know, you name it, right? They're all right there, and they're no problem spending those dollars. But Ireland's they're like, that's grand. We'll meet you at the pub and we'll chat about it. You know, and you're like, okay, let's go chat. You know.
Oh, too funny. Oh, you're too funny. Well,
Yeah, we
listen,
can
yeah.
whatever comes, whatever happens. I have 10 or 11 slides ready, and you know.
Well, listen, I mean, let me see if Dr. Burns didn't I he yeah, I maybe he just gave up. I emailed him back. I emailed him back asking him to come back in and turn his audio and video on. But well, let's see. Let's see. Hope maybe he'll pop back in. So, well, this is what I suggest then. I usually try and start with a I do the video 2 minute explainer, and then yeah, if you've got a few slides, let's do that. And are we going to talk a little bit about SWOT SWAT?
I have all of the slides are on SWOT. I think that technology and that satellite might actually change this planet and the way we see it. And I'm fairly convinced of that now. I was a little in Paris when we met with the CNES people and the JPL people and had a proper chat with them about it. But now I know I'm fairly convinced we could conceivably fix a lot of our problems, you know, a lot of them, maybe not all of them. But we need more power. So, you know, per the chat line that you have going, you know, we've got to figure out some free energy somewhere. Who knows how that's going to happen? You know,
Yeah, yeah, I know. Yeah, I know we do. That is great. It is great news about fusion, but I guess even in the most, bullish views, it's still at least like 10 years off or something.
so, you
But
know,
yeah. Okay, well, great. Well, good, because I've been, oh, that's great. I knew you'd have good insight on that. And it's fun for me because it's a French American cooperation, that surface water surface
ocean
ocean
topography.
topography. Okay, thank you. Okay, so let me start with the video and give everybody a second to kind of settle in a little bit more.
FrontierDAO is a decentralized, autonomous organization focused on scientific and engineering innovation. It is one of the first DAOs focused on scientific pursuits, hence one of the pioneers in DeSci, decentralized science. As a collective, FrontierDAO's main mission is to make scientific research, collaboration, innovation, and commercialization more accessible to wider groups of people, regardless of where they come from. Our philosophy, echoing that of NASA's, is that good ideas come from everywhere, and we are using the blockchain and Web3 tooling to help facilitate that people with good ideas, drive, and determination get access to funding, mentorship, peer support, and paths towards collaboration and commercialization. while still protecting their IP. Frontier DAO is committed to creating public goods by leveraging emerging technologies to benefit every human being on our planet. Catalyzing space and fusion technology incubation, Frontier DAO is working towards the vision of clean energy democracy. That is, clean, cheap, abundant, on-demand energy for all. By facilitating multiple pathways for funding for fusion energy innovation, Frontier DAO aims to collectively help make clean, affordable, and accessible energy available for everyone on the planet. We aim to do this by supporting paths to commercialization of this new technology, while still protecting the rights of the inventors and researchers to ultimately create a more vibrant, abundant future on this world and off-world that is shared more equally by all. Frontier DAO's work to support research as well as inclusivity in science, engineering, and the aerospace industry includes adopting space technologies to earth sciences to improve the quality of life on planet Earth as we simultaneously reach for the stars and become a multi-planetary species. Visit FrontierDAO.xyz today. If you have questions or would like to know more, feel free to reach out to co-founder Paige Donner on LinkedIn.
Okay, so I thought that'd be a good one. A good preface, a good jumping off point for you, since we talk about adapting space technologies for Earth. So I believe, I mean, you have so much expertise in so many different subjects. So I greatly appreciate you willing to hone in on this one for our presentation today.
Absolutely. Yeah, I think we're missing. You know, I took from Paris when we were there in September. I took that away, and I took that seriously. That we have to bring space down here, not to justify what we're doing, but to use the technology to our benefit. And I think that's that was the big takeaway for me from Paris. Besides, an amazing city, I felt like we were. I feel like we're doing that. I think NASA, ESA, JAXA, a lot of the space agencies are doing that. But let's continue on that path. I love the DAO. I think that's a brilliant idea. So good work.
Oh, well, thank you. Well, we need all I mean, we've got the vision, right? We need we still need to build out the brain trust. So let's talk later. Because I know you've got a lot up there. So any insight, but I appreciate the kudos. Thank you so much. So I think multiple sharing is on, but I appreciate you saying that was the big takeaway from the IAC in September. I noticed that too, actually, a lot, Terry. Myself, like all in the halls, there was just huge messaging about, space exploration, space technology is applicable to Earth. It's for the environment. And I think I think you're absolutely right. I think that gets lost a lot in the dialogue about space.
Unfortunately. Yeah. I do like the idea of reaching. And I think that, the technology we develop through, reaching, stretching our imaginations, that's massive. But at the same time, we have this amazing spaceship that we're on, traveling at about 227 kilometers per second through a universe, that we should be focused on this spaceship as well. Definitely.
Yeah, definitely. When you frame it like that, it makes so much more sense too, because it's just so easy to think that this is a stationary place that we can leave and come back to, which is the case. But when we think of it as its own spaceship, then of course we would want to take care of it, because it's our spaceship. it's our pool in the backyard, kind of a thing. So
who gets to clean the pool?
Yeah. Yeah, for sure.
I think it's funny. So, NASA, great at tooting their own horn, and of course lately they've been doing that, which I appreciate, even though I follow them closely. I do find it fascinating that that we're focused so singly on the moon. And I think the moon is a great idea. It's a brilliant place. It's terrific to go and talk about stretching, our technology. What is that going to do for us here? I have some ideas. I think I have some concepts that I'd like to throw around maybe in this conversation today. So we shall see.
Oh, I like it. I like it. Well, that's a great teaser. Yeah, why just focus on the moon? But I mean, it kind of begs the question a little bit then too. It's like maybe you're not talking about different planets either. Maybe you're talking about a whole different concepts of what space exploration can represent.
Yeah, definitely. Yeah, we've I founded this little organization, Space4All. We're a limited liability company. We're not making any money. Which is not the goal at all. I like to pay the bills, but that's it. I really feel our focus should be on the technologies we develop, how we can, use those to sustain our planet now. Energy is definitely on top of mind, particularly lately, with tokamaks and then what happened over here at Lawrence Livermore.
Yeah.
I say over here, it's literally over my shoulder, about 22 miles. It takes an hour to get there. Anyway, I'm convinced we're on the right track. I worry that we're at a fulcrum. I do worry that fulcrum can tip the wrong direction. I say that a lot. Maybe it's being pragmatic to be concerned, but we also have to be hopeful and continue in that vein, because I think that kind of, it's a clarity of focus, in my opinion. And yeah. So,
A fulcrum. So then what would be on one side and what would be on the other side? I'm curious.
well, I don't want to talk about complete disaster, but our planetary defense should be probably the most funded projects that we have, and it's not, unfortunately. And when I say planetary defense, I'm not talking about defense from the dark star. I'm I'm talking about, great example, 2019 August. I was in Nepal working on a water project. I get an email. It says we have a NEO that just came out of the sun. We didn't see, just came out of the sun, and it's 70,000 mile. It went by 70,000 kilometer, excuse me, by the Earth. It went through the geo and all of that, and of course it didn't hit anything. Thankfully, space is big. But that's a great example, right? We had 2 days to respond. If by chance that was going to be, a city killer or worse, and that concerned the heck out of me. That was in 2019. I remember that day vividly because I was with one of my sons. We're in Nepal. We're building a water project for people who use yaks to carry water around, and this is the year 2019. Just kind of put a different level of perspective. So that's one side of the fulcrum, is that we should be focused on planetary defense. Probably ought to know more about how the geology on Earth works. I know there are many people working on that, probably in this room today, who are focused on that, thankfully. But I do worry about that one side of the fulcrum. And the other side is that we stretch, we reach, we find free energy. When I say free energy, meaning we tokamak starts up, and then all of a sudden we've got free energy for as long as we want, right? Mm-hmm. And then it's just replication. Just go out, repeat and repeat. I do find that a very positive and enlightening thought. Worst case, we're another decade away. Maybe the best case, maybe the worst case is we're 25 years away. As I'm approaching 60 years old, I'd like to see that happen sooner. I also have, a large family. I'd love to, see peace on Earth. Let's get some let's get some peace working. The whole Ukraine thing just threw me over the edge as well. The deal, yeah. We should definitely be applauding that.
Yeah, great thoughts. Just to just just to back up just a second, can you just clarify what neo and geo are?
Yeah, near Earth the deal. NEO, near Earth objects. They can be anything bigger than a large car. If we get into the 700 kilogram or larger, we could have some serious consequences. The geo is a geostationary orbit, and it's usually equatorial, and that's where all of our comms are. Space-based comms, all of our relay stations are up there. If we want to, if you and I want to have this chat, we're not having this chat without a satellite. And I that's worrisome, right? That could have taken out a couple of our satellites, and those are $500 million approximately right now to replace. Takes 10 years to develop those little pieces of equipment that they're not big, they're the size of this room. But if you think about that, right, I don't think that's something we want. I think that we should really be focused on preventing that. This came out of the sun. So we do have a satellite that'll go up, I think, in 2028. It is a NEO satellite. It's developed for this very simple reason. We can use and blot out the sun, and we can perhaps see something run through the sun, come out the other side, and not be blinded by the light of the sun. And that's what happened in 2019. Nobody ever talks about that. I find that fascinating. That we in the business, there are only a few planetary protectionists, if you want to call them, who are thinking through that. And I wonder why. Maybe it's money. Maybe we just don't see the financial benefit to it. I think one big city done and gone could change things dramatically. And so I do worry about that. And so that's kind of that understanding the cislunar environment, that area between here and the moon, and how important it is. Here you are. That's why I was thinking about that today and last night.
Yeah, interesting. Yeah, really interesting. Yeah, you're right. One big city gone, and I think it would rivet everybody's attention on the matter. Yeah, and then another thing, let me back up again too, because in our little chatting about Paris and the IAC, I think I forgot to even kind of say, hey, this is Terry Trevino. He's the founder of Space4All, which is a huge deal, and so many other things that you do. Graduate of American Military University, aerospace. You've got your own company. I know you work a lot with various space agencies. I mean, you really are so humble, especially relative to everything that you do. Can you talk a little bit about probably one of the more well-known of your endeavors, which is Space4All? I mean, even at IAC, I don't know if you worked with them this year to have that as the theme, or if maybe they borrowed that from you. But that was definitely.
Changed it up.
What was that?
They changed it up. They put space FORE FOR for all. So I was founded before they named that event. So I take full ownership, but I use the number 4. Maybe a bit gimmicky, but yeah, we're Lee Steinke is a dear friend. She's also one of our advisors. She's at Cislunar Industries, and she goes, Terry, you're not a think tank. You're a get shiitake done tank. And I went, without cursing, sorry. I agree. I really think as we're presented these issues, these challenges, thinking through them takes not just you and I, it takes more than a village as well. We really have to work diligently to think through these issues. But almost need to be single-minded and focused. And I know at Space4All, my partner Hope, she's of the same mindset, right? We've got plenty to think through. You look at our project list, and it's significant, and it's just the two of us with our team of advisors. I'm busy enough that I feel like we have some growing pains, but I'm holding back because I want to just focus on a few things at a time and not lose that that mindset of getting things done. I do feel like we're I don't feel like we're stretched, but sometimes I do, definitely.
And the underlying motive is making space more inclusive, or what would be like the mission statement?
That I think you hit it right on the head. Space4All. All of us have the opportunity to see the benefit of what space can do. I do believe that bringing it back down here enables those of us down here to see those benefits, to feel those benefits. That's where I feel like, in my opinion, I think we're missing that opportunity down here. Is there are only a few top-notch science communicators, right, that are out and around. I don't consider myself that at all. I do love to talk about all things science. However, in our world today, we're certainly, maybe it's misguided, and sometimes I don't know if you feel this. Sometimes it feels to me like media kind of dictates what we choose to speak about, and that bothers me. I'm worried that happens with 4 children. I worry that my children aren't seeing the right stories. And so I thought Space4All, when I first kicked everything off June of last year, 2021, I wasn't sure exactly what Space4All meant, other than everybody needs to be involved. We all should be involved. There's no doubt that the industry of space in general should be everyone inclusive. My dad passed last year, and he was paralyzed. He would have done really well in space, right? Because the legs down here are just kind of a pain in the tail when you're paralyzed. And I always thought that was really interesting. And then, of course, at IAC, one of the event planners, who's also in a wheelchair, just went up on the zero-G flight and got to experience that last week, I think, or the week before. Got to experience microgravity or zero-G in that case. What a great experience. What a brilliant opportunity for yours and my friends who we know are missing limbs and not able to go out to space. And that's ridiculous. Please, come on, let's go. Let's open the world up.
Yeah, I love that. I love that you brought that up. And I know too that even the ESA, when they made their astronaut selections just fairly recently, what 1 or 2 people were people with quote unquote disabilities, which in fact, as you say, in space could actually be abilities, right? It's all about perception, isn't it?
Yeah, totally. Yeah, the one of the astronauts here in America, they call them ass cans. I don't know why, astronaut candidates. I get it, but it's kind of icky.
Yeah.
But one, I don't even consider that a disability, right? Down here, I'm sure it is, but up there, wow, you're 1 less limb and perhaps even a little easier to move around. Maybe it's not as challenging. I don't know. I can't wait to find out myself. I'll get on any list to go to space if anybody puts me on the list, and that's listening today. Put me on the list. Anyway.
Excellent. Yeah. And I think you are a great science communicator. You probably just don't, with all the engineering and all the projects you work on, you probably just don't have enough time, but you are a great science communicator. And I think another great science communicator too is Neil deGrasse. Oh.
Yeah. to sit in the same room. Wow. Well, I can't wait. I think I'm going to make sure I have that opportunity one day. I'd love to sit and visit in depth. Yeah, thought provoking. Every word practically that comes out of his mouth. I'm not saying I'm a disciple, but maybe slightly, just a little.
Oh, I would love to witness a conversation between the two of you because you guys are both such, you have such big brains, and you're so personable too. I think that would be, if that ever happens, please let me, if I can't watch in real time, let me watch on replay because that's going to be a great conversation.
I'll self-promote that one all the way.
Awesome. Awesome. Yeah. No, science communication, and yeah, having what your thoughts about media, I second those for sure. Yeah.
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 Who's running the media teams? Come on, let's go. Let's put some space people. I do like CNBC during the day sometimes. One of the presenters is a space junkie, and she's always talking about all the different rocket companies and technology, and it's really probably the only news station, if you want to call it, that I pay attention to, other than the BBC, which is spectacular about it. Yeah. Anyway, there you are.
Interesting. Yeah. And I wanted to highlight too your story about, about doing the water project with your son in Nepal, and then, getting the information about the near Earth orbit object, because yeah, you're right. Being with people who are still carrying their water, with yaks, exactly. And then, but then juxtaposing that with all these billions and billions that we're spending on satellite technology, which, as you've highlighted, we're using right now. Without that, the world would basically come to a critical stop. And
Right.
yet the lives are so different. How can we equalize things a little bit more? How can we pay more attention to this mothership, while still, reaching for the stars? It's like, how can we, how can we correlate those, or how can we justify the two, and not justify, but how can we harmonize the two endeavors?
Do, maybe do you think, when I say free energy, I'm talking about free in that nobody dies, we don't have pollution, we've got energy that's abundant. Sure, wind is there, brilliant. Who knows where that'll end, right? We've already seen that fail in Texas last year, with all of the wind turbines freezing up. Solar, absolutely. We could have one exogenous event and not see sun for 3 or 4 years. That would really deter any benefit of solar. I still think we need to pursue fusion, and we need to be aggressive. We absolutely should be aggressive about it. I'm concerned that it's not as aggressive as I'd like to see that. And think about all the money that we spend on all the other things, war and all the silly things. We should be working on that. Free and abundant energy would unify this world. And at that point, wouldn't, yeah, space-based solar power, yeah, true. I do. I think I was one of the first ones to say SBSP, brilliant idea. Could somebody accidentally just aim SBSP, electromagnetic waves, at something and injure us? Or yes, but hopefully that doesn't happen. Station keeping is going to be really important if we're going to transfer energy from space down to Earth. Station keeping, again, that's free energy. We've got batteries we're going to have to produce. We've got thrusters we're going to have to make, thrusters that work on either battery or some other type of xenon or other some type of chemical that we have to harvest. Again, energy. Everything is so energy consumption. It drives me crazy. One of the things I hope graphene becomes what I think it will. Transfer of energy from from one chip to the next. If we can reduce the loss of transfer of energy, the loss of energy as we make that transfer, it could even be, in a micron, in a distance of a micron. We're losing a considerable amount of energy when we transfer. Let's make that zero loss. I could be wrong. I think graphene might actually be one of the game changers as well. You think about the loss just on an energy line going across the street here. It's significant. It's up to 40%. Well, that's ridiculous. So we're making 40% at the power plant, but then as it comes to the house, it's 40% less, or excuse me, 100%. It's 40% less here. That's crazy. So let's make better energy transfer lines. Do you remember? God, it was in the 80s. They were talking about superconductive power lines, but we had to bring the temperature of the power line down to 0 C, and we're all looking at each other like, well, that's crazy, can't do that, and it just kind of stopped. And now I think graphene might be that next gen opportunity. There were a bunch of IAC graphene chats. I don't know if you got a chance to see any of those. I was astounded to think through that and go, oh my, I think we might be on the cusp of another big jump. If we could just get, that harvest graphene, you can get it out of the air. We can pull carbon out of the air, purify it, and make graphene. But it takes a lot of energy to purify the carbon out of the air. Hopefully that we figure that out as well. God, there's so many things to think about. Anyway.
Those are great points, Terry. Something just passed my desk just the other day, some kind of big headline saying NASA's getting into the business of graphene. So I know you're not just talking randomly. You're being your humble self and kind of like going, hey, this is a big topic. And then the other great thing I'm so glad you brought up too is, the energy loss in transmission, which is something that people don't actually pay, we don't pay a lot of attention to, or it's not highlighted a lot. But yeah, you're right. I mean, if a power plant has to, make 100 kilowatts of energy, and by the time it gets to your house, that's lost 40 of those kilowatts, boy, that's a huge, that's that's huge energy wastage. I mean, yeah, what can we even compare that to? So yeah, those are both really, really big topics, and I can't agree with you more about, abundant energy just being the single most transformative thing that our planet could actually and have as a gift, not to mention it propelling space flight too. So again, it's kind of like one of those technologies that could be both space and earth applicable. But you're right. I mean, remove the incentive for people going to war and what do you have? Maybe you have peace.
I think about the loss of war over my life and the tens of thousands, hundreds of thousands of people. And I always wonder, how many Marie Curie's died, in those wars. And I think about the Einsteins that passed, right, in those wars, the loss of life. We might be in a different spot today, and only in this short period, right? We're only 120 years of kind of these epiphanies that we're all going through. I just, it's disconcerting to know that we still support industry that chooses to do that. I know we have to, unfortunately. There are rogue states who think it's okay. But again, at the end of the day, is it energy that they're looking for? Is it more land? I don't think it's more land. I think it's abundant, free energy. And maybe graphene, maybe tokamaks. I think fusion is certainly on the way. Why not pursue fission right now, like you do, right? The power you're harvesting right now at your house is fission produced, likely. here in San Francisco, which you would hope that we would have that. We don't. We've got a coal-fired and gas-fired plant, coal-fired backup, gas-fired. Yeah, it's crazy, nuts. Anyway, I was thinking through what we might chat about today, and there are these. There's the CNO cycle, the carbon, nitrogen and oxygen cycle, right? That's really a part of what happens when the sun burns. And the CNO cycle, if we could harvest that energy out of fusion, we take care of everything. But what comes from the CNO cycle? Well, we get oxygen, potassium, some of the key ingredients, lithium. And the reason I wanted to chat about lithium is Cole and I, I think you know, Coleman Lutz, and I have come up with an idea on how to produce an environment where a battery doesn't have the loss that it experiences in normal conditions. And we think that might be game changing. And we're actively out shouting. I saw some comment today. We're shouting in the forest. We're shouting, but we're not in the forest. I think people are actually listening to us now. Finally, it's been a year, and I think that technology could change battery life considerably. Off-world, down here, other planets, and I think I'm fairly convinced, based on what the research I did here and the work, I actually built the device and tested it and everything. I'm convinced. We'll see if I can continue to convince the right people. Hopefully.
Tell us more. Tell us more. What kind of a prototype? That this is so fascinating.
It's really cool. It's so electrons spin, and when they spin, as they start to interact with photons, if you think through that, as two lithium ions are just sitting there minding their own business, an electron comes up. If it spins the wrong direction, then we lose that opportunity, that opportunity to create energy or to save energy, or to keep from losing that energy. And so spintronics is really what we've started working through, and Cole is brilliant at coming through and explaining it to me. When I started testing it, I started lining up the magnetic field, but it's a false field. It's an electromagnetic field. I lined it up with our Earth's magnetic field. I started testing the field itself. Started to see that we weren't losing. The field itself was reconnecting, which is really what, when you're working through electromagnetism, you're talking about connecting. It's almost like a butterfly wing, right? If you come up and out of the top and you come back, and so you don't want to lose a lot of that transfer from top to bottom. And once I started working on the right frequency range, and once I started considering alignment. So unfortunately, down here on Earth, we have to work on alignment as well, and that's another topic to chat about. Once I got through that, and I started seeing that I was not losing a lot of energy in the EM wave, and I thought, okay, let's start testing it on some other things. I started testing it on plants, just to make sure we weren't killing anything. Fortunately for me, it also is a means of protecting plants from high energy particles, alpha beta particles particularly, which is nice to have. It's kind of a side effect of the benefit of the device. It's literally an electromagnetic field that we created with a set of, quite simply, a set of Helmholtz coils, which have been around since the 60s, I think even the 50s. But again, it's one of those things where it's old technology. Now all of a sudden we've got new transistors with new switches. We've got computers that can kind of give us the benefit of visualizing where the fields are. I even used Python to determine the field itself and all the vectors associated with the field as it rotated around. It was very fascinating and another little epiphany. Like I seem to have these every few days, few weeks, depends on, what I'm working on. But it validated that we know we can control the spin, the electron spin. That to me was probably the more important part of that test. Let's see where that lands. I'm presenting that throughout this year, that device in different forms, and we'll see where it goes. I'm excited. Down here, it's health benefits as well. Oddly, we think we can move fluids around kind of freely without the loss of or swelling of a body, right? Let's say down here, you've got glaucoma. Glaucoma is really just an increase in pressure in your eye, and a blockage of an inlet, right, in your eye. The reason I know this is I have it, and so I started thinking through. Well, if you keep things moving in your eye, and you keep that fluid moving, you don't have the same buildup of pressures. And I thought, well, this is really cool. So we're working on an ocular version of the same thing, an EM field. We do pulse our fields. That's an interesting part of what we do. The pulse is a very large increase in the field's influence. So the SOI, the sphere of influence, is much larger when I pulse. We still get a return as well, which is also very exciting. It's pretty fascinating technology. I didn't think it was possible to make and control. I was told I couldn't control it by pundits, and they were wrong. And I proved them wrong. And Cole and I are out talking about it often.
Help me understand how that would the end application could relate to batteries.
Yep. Batteries themselves, as they sit idly, right? The ions themselves interact, and you get a loss, and they interact with just free. I call them free range electrons. They're just kind of randomly moving around as they are, without any benefit, right? So with that, so every time those ions burn, let's call it that, you lose it. It doesn't come back. It's gone. So your battery life is decreased every time. And sure, you can recharge, but you're never going to recharge to the exact same percent, because that battery is losing its life slowly over time. Yes, I do worry quite a bit about the amount of water used to harvest lithium for Li-Hi batteries, lithium hydride batteries. I do worry about that a lot. I think that's a tremendous loss of water. They don't use seawater as well. They do use dirty water, but CNO cycle, back to the CNO cycle. Oxygen is probably one of the most important things that was created part of the CNO cycle, and lithium right there with it, right? Lithium's much more abundant. And I started thinking through CNO cycles, oxygen creation. What's the most important thing we need? Well, we need water. Water is a combination of hydrogen, which is everywhere, and oxygen. And here we are today, alive, thankfully, because of those two abundant chemicals, and a nice little mix of whatever happens down here on Earth. That's why. So, kind of tying to SWOT, surface, water, ocean, topography, and that satellite that launched on December 15. That satellite and our knowledge of clean water, fresh water, the sizes of these lakes, these storage tanks, if you want to call them, that's game-changing information. But the movement of seawater, I think, is one of the things that when we were in Paris chatting through CNES, and they were talking about, and JPL talking about what, yes, my question was, can I see the water's movement? Can I decipher its movement and its speed, and not just direction, but maybe even some of the undercurrent? Once I started thinking through that, then I started thinking about the value of how, water to us as a species. And that technology is fascinating. I do have a set of slides I'll share with you after the fact, and you can take them and maybe post them. They're all referenced and everything.
Oh, well, I was just going to suggest maybe because people might not know what SWOT is because it's so new. I have I think I've got a I thought I had it. I thought I had it here. Um well, we are having a great time just chatting, but it's true, it is, it's very fun, and plus it's the holidays, so we can't get too ambitious here, but it would be kind of great to talk a little bit about SWOT.
I can fly through the slides. They're if you don't mind.
Do you want to? Yeah, well, if you don't mind, yeah.
I'm ready. I was ready to bring them up.
Okay, cool. All right. Yeah, okay, great, because my screen is taking its time to boot up.
Here we are.
Oh, great.
That image is spectacular, right?
Oh,
there's the
gorgeous
definition of life right there.
That's gorgeous.
SWOT, I firmly believe SWOT will change our knowledge of our planet. We see other planets, other moons that are water worlds. We're not a water world. We're as a water world goes, we're very we've got a lot of dirty, bad water and water that we can't use, certainly for our benefit. Yes, sure, we can remove all of the salt and drink it, but that's also a lot of energy to do. I don't know. Let's see where it goes. SWOT is a very simple and I think probably one of the most impressive instruments that we've launched recently, besides JWST. So life cycle costs for NASA and CNES were in the almost 1.2 billion range in terms of investment. It also works with these two. You can see these two arms kind of moving out and away from the satellite. That allows you to get a cross-track resolution, so you can get one reading this way, you can get another reading this way. So you're working now in 2 dimensions, and so you'll be able to see water elevation change. That to me is huge. And now we're really going to know how fast our water world is increasing, how much water is increasing because of the melt, snow melt, ice melt, polar cap melt. Oh, I don't even want to think about that. Anyway, I'm just going to show you the pretty pictures. Real quick, it's a 92% of the planet. So it runs at an NPO, near polar orbit. So it's missing, it is actually missing the caps themselves. So when it goes around Earth, it just kind of pops around and misses the caps on either end. But nonetheless, we're going to get some really good detail. The multispectral radiometer, that's huge. That tells us elevations of the fluids themselves that it's reading. It gives us sea level numbers. We also have a gravity field measurement on there. I'm also concerned about gravity and our magnetic field in general. So it's going to help us understand that more. Gives us some really good information on a lot of different water environments. I think that's spectacular. Again, I'll share these with you after the fact, and you can spread them around. Again, reiterating, we're going to know how fast and how much water we're seeing in terms of melt and how quickly it's changing. And we're going to be able to tell that really quickly, unfortunately. And probably, I was told by the principal investigator they'll be tested out by middle of the year, by end of 2023, beginning of 2024, we're going to be getting some good detail. unfortunately. I mean, you know, let's use that as a tool, right? Unfortunate that it's going to tell us some really stuff. It's going to tell us things we know that are not positive, but we need to use that as a tool, right? It's just another tool in our quiver. Hope and I started thinking through at Space4All about pollution in general and polluting sources. So what's going to help us discover temperature gradient changes as you might have an effluent that's coming out of a plant that's manufacturing whatever clothing or whatever textile it might be manufacturing. We're going to see that plume. We'll be able to see where that plume comes from and where it's being emitted. And then we might be able to, you know, protect our waterways more so, even more now. And Landsat 9 really got us to that point. Landsat 9 is another satellite that's up and working right now. And I think if we can get down to this 20 cm number, that we're 20 centimeters, that's spectacular. Be able to see that tight, that narrow of a field, that's going to be wonderful for us, all of us. Just giving an idea of the latitudes where we're going to hit. So we're going to be at 78, 78. That's significant coverage across the planet. Can leave that for later. There's your partners in it. Canadian Space Agency, NASA, CNES, UK. JAXA has an instrument on there. There it is. That's the instrument itself. And, you know, it doesn't give it an idea on scale, but, you know, these little wheels down here, and everybody knows what these little, you know, these little pathways that they've protected around the spacecraft. So you kind of know that that's about, what, 36 inches high. So you get an idea of the size of this thing. Big. This is really cool mission architecture. For anybody that's keen, come back in and check this slide. It's on the NASA JPL slide too, or excuse me, NASA JPL site. You want to go and get a good idea of all of the things that we're going to get. It's a lot of data. There are already papers out assuming what we were going to see and the benefits of it. And let's see if we can. So a lot of what we're going to need to do is going to be ground confirmation. So we will have to be in situ. We'll have to be on the surface. We're going to have to measure the temperature of the water coming out of the potential plant that's polluting. Measure that water temperature, and then get that architecture matched up to SWAT. There are teams that are doing that now. Microplastics are our biggest concern. You can get an idea of the fingertips down here in the lower right-hand corner. Those are so tiny. They're finding them in our blood, right, in our body. They're finding them in our major organs. They're finding them everywhere on the surface of Earth. And hopefully SWAT, is going to help us find that and clean those sources up. These are the micron sizes, and I think so it's a micrograms per milliliter. And look at these, we're at 12 micrograms per milliliter. PMAA, PP, PP is not in that one. That's polypropylene. Polyethylene is the big one here. You can polyethylene is plastic bags, milk bottles, milk jugs. And there's my references. That's it. I'll keep that for you, and you can always have access to that. I'll send that to you.
Oh, thank you. Those are great. Yeah, and your opening slide, it's like the creation of life or something. Yeah. Wow, that's fascinating. So how did you how did you have a rapport with the PI, with the principal investigator? That's kind of cool. But I just have to ask.
He was there at the NASA pavilion, and it was just a chance meeting, and I asked a question, and we visited after, and right time, probably right place, certainly. All of it kind of lined up. I had thought SWAT would change things. I didn't really think it through until I saw the instrument package. Once I knew the instrument package that was on the bus, the satellite bus is what we call it, I was convinced that with that, knock on wood, right now the orbital insertion is good. They're starting to test up and they're starting to turn things on. We should be getting some reports pretty soon. I'd say within the next couple of weeks about its overall health. I'm sure it'll be fine. I didn't used to think that anytime anything lifted off of of any rocket launch pad, I used to think it was going to blow up. And then, SpaceX started changing that for us, thankfully. Yeah. So let's see. Let's be thankful that we have SpaceX, to be honest with you.
Yeah. Yeah. No, that was great. It was so succinct, but so powerful. We only have a few minutes left. I want to open it up to questions. And also I don't want to overlook, I don't want to jump around too much, but I don't want to overlook Adil's comment earlier when you were talking about your project that you're doing with Cole. He said, it's in the chat, he said, idea, I think it was right when you're talking about the glaucoma and fluids.
Yeah.
Maybe it can clean plaque in heart arteries.
I think it depends on the metallicity of the plaque. If our blood, which we all know has iron in it, it may not be a significant amount of iron to overly influence blood. We have a theory that in the brain, we think we can control that orthostatic imbalance that astronauts are seeing with their long-term missions. We think we can control that. Down here, we are definitely thinking through how best to use the devices. Even with a cranial cap, we also think we can influence different parts of the brain, and we're working through that with a partner in Portugal who is a PhD physician, and she's been fantastic. We have another physician who's a PhD physician out of South Carolina as well, helping us through that as part of the team. I think I'm going to look through that. I do know that the blood is ferrous. I don't know how ferrous, and I want to make sure that that's something that will be tested. It's really, as you well know, getting an institutional review board, an IRB at any university is not easy. And we've already started the process with our IRB, but we're expecting it to take 6 months to get approval. And that's to test on astronauts on the ISS. And that's where we're at right now in terms of development phase. So the technology is ready. I just need to know that I can test safely on humans. They had suggested, the ISS cases folks had suggested we test on mice first. I guess we're going to have to do that, and that's the plan right now.
That's a big step. Yeah. I mean, testing on anything live is, that's a big, it's exciting though. Boy, you are making progress. Those are really big hurdles to work through. Yeah. Did anybody have a question for Terry? If you're welcome to raise your hand or even just unmute. This has been a great, that was, and you've mentioned, I caught a talk that you gave not too long ago. I caught it on replay about electromagnetic fields. And I know you've mentioned it too during this conversation, sort of in passing a couple of times. And I know that's a whole other topic, but boy, that is a very fascinating topic that you are also very learned and expert about in terms of
It's funny, Paige. I started particle physics and educating either myself or through classes when my first child was born 19 years ago. And I always thought, as the fundamental forces go, right, the four fundamental forces. So you've got strong force, weak force, you've got gravity, and you've got electromagnetism. And electromagnetism was always in the room, but never getting the attention. And I think it was because of LIGO and Virgo, and all of a sudden the discovery of gravitational waves. And I didn't see the comment question there, but I'm convinced that EM fields themselves, because we've had them here on Earth, are for 400 million years plus, and that's as far back as we know. We likely had electromagnetism or a magnetic field much way before that, but influencing life in general. So we know we have to bring it with us, right? We know we can't just go out into space and go, oh, we'll be okay. We already know we'll die immediately if we just open the hatch. So let's bring everything we can to space so that we know we can survive off world on the lunar surface, bringing our EM fields with us, which is a project that I'm working on for my PhD. And by the way, I think I'll probably be the oldest PhD ever. Probably not.
I wouldn't. No, I wouldn't.
Maybe. I spent 20 years, kind of co-raising, co-parenting. And so I really, all we focused on here in San Francisco was raising the kids, keeping them healthy and happy. Yeah. But yeah, in the meantime, yeah, EM electromagnetism, I don't know what happened. It just, now all of a sudden it's just clicked for me, and I'm all in for anything EM. When I look outside now, I think, wow, our EM field and its strength, or magnetic field and its strength, varies to the surface of the Earth, right? It varies in terms of its height off of the ground, and you're like, oh. So we can get up a bit higher, and we're not as protected, right? The Himalayas. When I was there in the Himalayas, everybody has weird cancers. They have ocular problems that are all brought on by no electromagnetic field or no magnetic field protecting them. And that's the reason why they have that at higher elevations. Anyway, another thing to think through. Jonathan, anything on your mind?
Well, first thought, isn't that a thing with Artemis? With the next flight, they're going to be further outside the field than anything.
Alan.
Well, ever, right? It's going to be the furthest flight.
Yeah, zero protection up there. Well, what's funny is that yeast experiment. I was fascinated with the yeast experiment because I'm really keen to know how it does outside of the Van Allen belts, which are at what, 800 kilometer, I think. So when Polaris Dawn, actually 500 kilometer. So when Polaris Dawn launches, they're purposely going above the Van Allen. And for a reason. And I think they're going to be doing quite a bit of work up there. I'd really like to get some numbers on that mission if I could. Let's see. I'll beg and plead with someone to give us a ride. But a friend of mine owns Relativity. I don't know if you know him, Paige, but Tim, he said, Terry, anytime you need a ride, I'll get you a ride. I could use a ride. Not me personally, but if you don't mind taking a few of my experiments up. But I don't think they're going to go outside of the Van Allen belts initially. Their first launch, which I think is any day within the next few weeks, all 3D printed rocket, everything, almost every component, other than I think some of the feed lines for the turbo pumps. You're like, oh, come on. This is another game-changing piece of technology. Let's hope for the best there.
Yeah, absolutely. And for people who don't know what you were so subtly alluding to, that's a 3D printed rocket ship that's launching into space. It's called Relativity. Yeah, one of like the junior SpaceX. I mean, boy, those guys are impressive.
Yeah, that's I think that will take the iteration numbers, the per kilogram numbers should take them down quite a bit if they can get that rocket launch. There's Astra Aeronautics just across the bay, and they just can't seem to get, everything working together. You know, unfortunately, they're at the whim of the public market. I don't know why they decided to go public to raise money. They probably shouldn't have done that, but in retrospect, they probably are living and staying alive because they did that. I don't know if you remember that when it launched it in Alaska, they launch out of Alaska often. And so it launched and then it kind of moved, it moved over about, I don't know, 10 meter, and then it took off. Like, when it was taking off, I don't think it's supposed to do that. Anyway, of course it failed, but I think they're getting there. Their second stage rocket, their second stage rocket motor looks fascinating. So I hope that works. Space Elevator, who's that? It's talking about that. You know, that consortium are very strong. The Space Elevator Consortium, they're interesting. A lot of really top-notch PhD folks in there have been talking about it for a long time. Talking about, what can we develop? Can we, Michael Lane's always talking about an elevator to the surface of the moon. I think that's a brilliant idea. Out of L1, it's a really stable orbit. You don't have to move around too much. It's easy to get down to the surface. I think that might be a game changer. Yeah, Peter Swan. Yeah, I actually met him in Arizona this year in October. Wow, what an impressive personality, and great voice, and just big man. Anyway, it's a really cool person to just sit and visit with, chat with. So many great people in our industry.
Oh yeah, that's true. And you're definitely one of them. And with that, I really want to respect your time, especially because we're pulling you away from your I'm sure you're having, wonderful family holiday times, and you've been so generous with your time and your knowledge and just all these fun things. And the way you mention them, you just mention things so subtly. It's like you kind of have to dig in there a little bit to see what you're
So, someone said it's like I took it as a compliment. I don't know if it was. It was
compliment.
Like Mozart on ADD, and I went, "Oh, Mozart on ADD, maybe, maybe that's probably pretty good."
I like
this.
that.
I love music. You can't see behind me, but I have my trombone. I have a guitar. I love my music, but yeah, there's so many things to think through in our world every day, and we should all be thinking deeply about it every day. It's our job.
If I may, say thank you very much indeed for your talk. That's fantastic to listen to. There's a lot of stuff going on there, and a lot of things, different technologies and ideas have been mentioned. Is there any way you'd recommend someone getting involved in these?
Yeah, for me, it was just diving in. I dove in head first, knowing that I'd get a head injury, and there were a few along the way. It took the better part of 15 years for me to kind of perfect my knowledge, but I've only improved my skill set over the past 60 months. And I'm not thinking in a monthly fashion. It's been 5 years. So get involved. Do you know what I did? I joined AAS, which is American Astronautical Society, RAS, Royal, which, if you're in the UK or anywhere over in Europe, they're some of the most brilliant minds ever. I read volumes, and that's probably about 20% of what I've read in the past 5 years, volumes of books. Some of my favorite, Brian Greene, definitely a little on the edge of madness, which I like. Sean Carroll was game-changing read for me, any of his books. Lately, it's Sabine Hossenfelder. She's a German physicist, theoretical. A lot of theoretical physicists. So Leonard Susskind, he's down here in Stanford. He's literally, and he lives over here in Mill Valley. I'd love to sit and visit with him. Yeah, there are some of the great minds that are still out and alive, and I seek those minds out. I do go to any talks of any of those So is it World Science Foundation? Is it WSF? I forget the name of Brian Greene's foundation, but it's spectacular. He has amazing talks. Sean Carroll has a really cool podcast. It's a Q&A podcast that I like a lot. Yeah, we need, I have 2 daughters, so I'm like, come on, girls, let's go. We need that perspective as well. I have many dear friends in India and Nepal who are close friends who I consider, people who I revere. Chandra Sekhar. God, I wish I could have sat and visited with him. Yeah, there's so many great reads out there. If you don't have time to read a book, pick up the audiobook. I will often be driving around delivering children to and from different places, and we'll have my audiobooks playing. Drives them crazy, but I think I hope by osmosis they're actually learning. Hoping. Anyway, that's all I can give you, Eric. There's plenty of sources, right? I do think that joining IAF was a big one for me, and I did join as a lifetime member. I think that gives it that international feel. I don't think I'm going to Baku. Are you going to go, Paige?
No, I don't think so.
I don't think I'm going to go to Baku. I'm definitely going to Milan. 100%.
Good choice. Good choice. Well, that's a great reading list. A few of those I recognized, not all of them, I'll admit. Maybe after the new year, I'll follow up with you and ask you to maybe notes some of those, or I'll listen on replay and write them down and share them on social media in case people would want to take up your.
Got a list of 70 that I can kind of collate for you. And
okay.
70. So yeah, that's the number right now. I consider them the most influential reads that I've seen and had in my hands the past few years. So yeah, happy to share that with you.
Wonderful. Well, that'll just be for starters, just the 70. Boy.
We'll get that thing out soon.
Oh, Terry, this has been so fabulous. I really want to say thank you so very much. Obviously people have really enjoyed, your insight and they get it too. They understand what you're talking about, where you're coming from. So any words of wisdom, any more words of wisdom you'd like to leave us all with?
Yes, I say this often. To answer a deal real quick, International Astronautical Federation, to answer that question for you, IAF. If we could all take these moments during the day, these quiet moments, and realize every opportunity that we have to make a difference is there in front of us. We just have to reach out a little. We have to step out of our comfort zone a bit. Don't worry about what people think about you as much as if it's important to you, make your voice heard. Speak up. I think that's the biggest thing we can take.
Wonderful. Wonderful. Thank you so very much, Terry. Yes, wishing you a fabulous last couple days of 2022, and I'll wish you Happy New Year when the clock turns in like next week or something sometime.
Definitely.
Thank you, everyone. Thank you for joining us, everyone. Very, very happy holidays to everyone, and we'll see you all in the new year.
See you soon.
Thank you very much.
Thank you.
Thank you. Happy New Year.
Bye. Bye.